And to get us started off today, my goodness, you know what it is? It's problem of the day time. Let's see what we've got here. Find the distance between the points. We got -5, 2, that's a coordinate by the way, and 7, -3 on the coordinate plane. So once again, we're looking for the distance between these 2 points. That's -5, 2, which is one coordinate, and 7, -3, which is our second coordinate. And on the coordinate plane, this kind of tells us it's a graph situation, perhaps. So let's talk about this thing just a second before we go to a coordinate plane. One thing I'm going to explain to you here, when we look for distance, there's a couple ways we can do it. We can draw the picture that these 2 points, make some good things happen with them, which we're going to try doing first. But also there's a formula called the distance formula. So once we get onto our graphing paper, we're going to play with the distance formula also and show you, you will come up with, yes, the exact same answer. Has to be, right? Has to be. Because you know what? Distance is hinging on a certain fact that we're going to look at on the graphing paper. So if y'all can take me away just a second here, let me get a piece of graphing paper pulled in here. If we can, thank you. Let's see if I can do this quickly. And here we go. There's some graph paper. Let's take a look at this. It's got it all pretty up good. And we want to find the distance between, here's the first point. It is -5. And we'll go up 2. And we're going to take it 7 and down 3. Looks like there's a pretty long distance there. So what are we trying to figure out? Well, we're going to find out the length of this line segment. That's distance between 2 points. It's always about a line segment. You can't do distance of a line. Can't do distance of a ray. It's got to be a line segment. So there we go. Well, that was pretty easy, wasn't it? Unfortunately, they are horizontal blocks or vertical blocks. So we have to work a little bit for this. Now we will make sure we put it in the right place, because if we're off by points, I'm in trouble. We're all in trouble, and they'll get, you know, whatever. With -5 up 2, that looks good. 7, and then we're going to drop down 3. It looks really good. Now, what I want us to do, we're going to, and it's 6 of 1, half a dozen which of these you've connect. I am going to create a right triangle here. You say, well, why are you going to do that, Ernie? Because I know something about right triangles, and I bet most of you all do too. And what I'm going to do, I'm going to go from this point horizontally, because I can count horizontal blocks, all right? And I'm going to go down because I can count vertical blocks. Pretty easy. And I bet all of you can tell me what kind of angle I've just created here. There's a nice perpendicular, because these slopes are opposite reciprocals. My goodness, well, there's 0 and undefined, so that's about as opposite as you can get. I don't know if you want to say opposite reciprocals, but they certainly are reciprocals. But opposite, well, you know, 0 is neither positive nor negative. But you get the idea. We got a right angle there. We got a right triangle. And what we're going to do, we're going to simply count blocks. How easy is that? And it is. We're going to count. Looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I'm going to put a 12 down here, and I'm just going to signify that is my length going all the way out through there, all right? Now, notice that's the leg of the right triangle. And some of you are starting to think, oh yeah, Pythagorean Theorem maybe? Pythagorean Theorem, yes, we're going to be looking at that here in just a second. What we need to do now is count, we've done the horizontals, let's count the verticals. 1, 2, 3, 4, 5. So we've got 5 going to the top of this picture. Well, the top of the triangle anyway, not the top of the picture. And, wow, we got a 5 and a 12. And I mentioned something about good old Pythagorean, all right? So remember the old formula, a squared plus b squared will equal to c squared. Now, our a, b, and c, the a and b are the legs, c is your hypotenuse of this right triangle. And my friends, notice something. It's also the length of that line segment. So we're going to work it through here. We're going to pick up 5 for one of the legs. It doesn't matter which one we put where, because they both square and go positive, and we got a plus in between, so it doesn't matter which we call A or B. I'm going to use 12 here for my second one. By the way, we want to make sure to square that. Otherwise, we will have a goofy answer. And we will do the same thing here. We will square the 12, and we hopefully will get c squared. Now, if y'all drop my lower third out for just a second here, we're going to do some squaring. It helps folks to know these perfect squares. When you have a problem like this on the ACT or the SAT, you've got so little time to figure it out, but it's all there waiting for you if you know these perfect squares. Also, if you know the triple, 5, 12, and something, which once I get to you at the end of this thing, it's one of those things to commit to that memory that may help you out on one of those problems. We got 25 when we square 5. Everybody knows 12 times 12. You learned that in 3rd grade, right? I hope. Anyway, there you go. And we've got a c squared hanging on for dear life out there. Add those together, I get a 169. And that's my c squared. Now that's the beauty of this one. 169, it is a perfect square. So let's square root, run right through it. And you know what? That's going to give us c because that's what it does. It offsets the c squared. 169 is a perfect square. It's just a little bit above 144. Well, it's going to be 13. And 13, my friend, that is the length of this segment. Now you say, Ernie, what happens if it didn't come out to be a perfect square? You probably would be wanting to change it into some sort of, hit the calculator, take the square root of it, make it into a decimal, or if they ask you for a simple radical form, you would work it down into working through a square root type situation, okay? Where you'd have like maybe 2 times the square root of 5 or 5 times the square root of 2 or something like that, depending on what you're ending up. And you might end something like the square root of 61, which won't go anywhere. But in this case, it was perfect square, came out 13. There's your answer.